Okay, so in our last lesson, we talked about box and whisker, kind of the different parts, how to read it above a number line. We talked about it, that it usually comes from some kind of survey or some kind of data that we get somehow, some way. Okay, so I made up a little fake story about iTunes and how many, the iTunes app and how many people downloaded songs, or how many songs I should say were downloaded off that app, right? So I had you guys step forward and back. Okay, let's say that Mr. Mua, for example, in his class, in a different classroom, he randomly selected 8 students and had them do the exact same thing, and he wrote down the numbers as well. Now, the numbers aren't going to be exact, right, to ours. They're going to be different. So what we're doing in this next lesson is we are going to take our results and we're going to compare them with his results. Okay? That's what this next lesson is. So it's taken, for example, some graphs, and especially some box and whisker graphs, and looking at them and comparing them. And I'm going to show you how, as a 7th grader, you're supposed to take a look at that and do that. Okay? So, just a few vocab words, and these are in your vocabulary. So green on the left, notes on the right if you don't have them out. All right, our first word is called the double box plot. Everyone?
Double box plot.
All right, so your book says these are 2 box plots. So that a box plot is a short name for the box and whisker we talked about. 2 box plots graphed on the same number line. And that's what I just put there. You could write in your little box off to the side. 2 box and whisker plots stacked for comparing. 2 box and whisker plots stacked for comparing. Our next word is called the double dot plot. Everyone?
Double dot plot.
It's kind of fun to say, right? A method of visually displaying a distribution of 2 sets of data values where each value is shown as a dot above a number line. Okay? So I want to show you, if you've never seen a dot plot before, there's a number line. Let's just take it easy. 5, 6, 7, 8, 9, 10. Okay, here's what a dot plot would look like. Let's say that someone downloaded 7 songs. Another person downloaded 9 songs. The third person we survey says, I downloaded 7 songs. Then someone downloaded 10 songs. Then the third person, or I should say the 5th person said, I downloaded 7 songs. Okay, that's what a dot plot looks like. Each dot represents each value set or data. Okay, in this case, each person or how many songs they downloaded. Okay, and it's almost kind of like a bar graph in a way that you can compare by looking at the height of them as well. All right, so that's what a dot plot is. So a double dot plot, you can write in your little box there. This is 2 dot plots stacked for comparing. 2 dot plots stacked, one on top of the other for comparing. Okay, I'm going to fly through these next 3 vocab words because they're not on there for you to write down, but that doesn't mean that they're not important because you're going to see them. They're actually in our instructions. You need to know when they say this what they're asking for. All right, so here we go. Our next one is measure of center. Everyone?
Measure of center.
In this particular lesson, they're going to be, if they ask you for the measure of center, they're asking you for the mean or for the median, depending on which graph it is. We'll talk about that. The next one is measure of variation, everyone.
Measure of variation.
when they ask you for that, this is the interquartile range, as well as something you guys briefly learned in elementary school, and you'll talk more about it in 8th grade, the mean absolute deviation. Okay? And the third one is the interquartile range. Everyone? And this is the distance or difference between the first or lower quartile and the third or the upper quartile. Okay, we talked about that last lesson. Okay, I want to thank you, those of you that were listening to me. It kind of worries me whenever I said, guys, I'm going to move through this fast because it's not in your vocab to write down, and then everyone starts looking to write it down. Okay, it worries me a little bit that a lot of us aren't listening. Let's refocus. Okay, because that is a little worrisome as a teacher to hear something like that. That proved how many people weren't listening to everything I was saying. All right, so let's refocus here. Okay, thank you those of you that didn't do that and were listening. All right, here we go. So when we talk about comparing populations, all right, let's go ahead and let's take a look. Grab our worksheet, of course. And let's stay on the very front page. Actually, you know what? We'll come to the front page later. Let's look at that second page, the homework practice side on 10.4. All right, let's go ahead and let's take a look at our directions, because that is pretty important. Here we go. Compare the centers and variations of the two populations in each exercise. Round to the nearest 10. If necessary. Write an inference you can draw about the two populations. Okay? So, they're asking us to do three things. They're asking for us to compare the centers, compare the variations, and then they want us at the very end to write an inference. Okay? You can draw. All right? A conclusion. Okay? So, those are the three things they're going to ask us. All right? Now, let's start with problem number 1. Okay? Fitness is the kind of overall topic. But let's take a look. It says the double dot plot shows the daily attendance for 2 fitness clubs for 1 month. So in 1 month, how many people come daily? All right? Every day. So they kind of tracked how many people went and worked out, and they graphed it as a business. So it says fitness club daily attendance. So you have 2 different places, 2 gyms. One is called FunFit, and the other one is Greg's Gym. All right? Now if you take a look, right, the range for these graphs, you can just look at the number line, is anywhere between 80 a day to 140 people a day. All right? And all of the results are here that are graphed. Okay? Now, here's what we're going to talk about. Step 1, I'm going to write right up here. We're going to talk about the center. All right? Now, if you say, well, Mr. Wilkins, what are you talking about? Well, that's why we went over this. I told you it was in the directions. It's the measure of center. It's asking for the mean or the median. Now, I'm going to kind of color code this. So in this first problem, I'm going to write everything in red because it's a box and whisker plot. Okay, a double box plot is what they called it. So when you're dealing with a double box plot, we're not dealing with the mean, right? It was just from our last lesson. These, the center parts, are the medians. Okay? We're finding the center, the medians. So, I'll continue down here. Step 1, the median. Okay? For FunFit, the median for FunFit is this right here. That's the median for FunFit. The median, that middle part, is 100 people a day for FunFit. That's our median. For Greg's Gym, the median, I'm looking at Greg's Gym box plot. So right here, it's 120 people a day. Now I'm going to come down here and do the next part of step 1. Right? I've identified them, and now I'm going to write them out as a sentence. All right? So here's an example of what you can put. The median of the daily attendance, at FunFit is 100 people. I'm putting my units there next to 100 people. While, little easy transition to the next one, while it, we've already defined that it's the daily attendance, while it is 120 people at Greg's gym. So all I did was I took our data up here and I compared them in one sentence. I just listed one and then listed the other all in the one sentence. Median the daily attendance at FunFit is 100 people, while it's 120 people at Greg's gym. Okay? Now, step 2. Step 2 is the variation. Well, variation in here, the measure of variation is either the interquartile range or the mean absolute deviation. Now, considering we're dealing with box and whiskers, we're going to deal with interquartile range. And if you remember right, that's the distance between the first quartile and the third quartile. We talked about that briefly last lesson. Okay? So, right here I'm going to put, for the box and whisker, is interquartile range. This is the middle 50%. What this does is it kind of gives us a major focus and it gets rid of those major extremes. Remember how we had all between 2 and 12 music songs downloaded? But you had the one person, right, that downloaded 50 songs, way too much. It kind of ignores those extremes because every once in a while there is an extreme like that. Okay, so the interquartile range gives us that middle 50%. Okay, so here we go. Step 2, let's go ahead and identify. I'm going to put just IR for interquartile range. So here we go. For FunFit, the interquartile range for FunFit is, here's our first quartile and here's our third quartile. It's between 90 and 120. So I'm going to put, for note purposes, 120 minus 90. Our interquartile range is 30 for FunFit. Now we move to Greg's gym. Interquartile range here is between 110 and 130. So to find that, for note purposes, 130 minus 110 is 20. All right, and then we do this. We go ahead and record that in our writing, those results. So here's an example. You could say the interquartile range at FunFit, proper noun, right? So it's capitalized, is 30 people, comma, while it is 20 people at Greg's gym. Now, step 3 is we need to write an inference or a conclusion to what we can look at here. So that is part of step 3. You need to read this. You need to read that, and you need to read that and find out what exactly is going on. Now, if you take a look, on any given day, the maximum at both could have 140 people in it, right? However, if we take a look, remember, the top, for example, the top 50% at Greg's Gym runs between 120 to 140 people. Look at the top 50% here. Just 100 to 140. Okay, look where our box is. That shows you the middle 50% goes from 90 to 120. This one is 110 to 130. That's the middle 50%. All right? It's easy to say that for the most part, even though they both have the same extreme, a majority of the amount of people that come is up here for Greg's Gym. Okay? So here's what I'm going to write for step 3. I have a little closing phrase. In conclusion, Greg's Gym has a larger daily attendance, and here's what I'm going to put, overall. Because any given day, right, FunFit could have more people than Greg's Gym. But overall in that month, looking at our data, Greg's Gym has a larger daily attendance. Okay, not a lot of math, just a lot of writing. This is kind of almost an A-B. You have to be able to read, of course, your graphs, understand what median and interquartile range is, okay? But once you read that, all you have to do is write your results. Okay, questions on this? On any part of this? I'm about to let you try one. All right, here's the problem I want you guys to try then. Okay, same page. I want you to do problem number 4. Problem number 4, all right? I'll check in with you guys in about 2 minutes. Go. All right, checking in. How many of you still need more time? Okay, I'll give you guys about another minute, and then I'm going to have you guys share what you do have at that point. All right. Even if you're not done with the writing at that point, you'll at least be able to share it verbally and then just record it later. Okay. So at least get all the math part done. Okay, guys, I'm going to go ahead and give you guys 1 minute to go ahead and turn to your neighbor and share your go ahead and share your writing. And even if you don't have writing, share what you are going to write based off of what kind of math you did. All right, 1 minute, go. Okay. Here we go, number 4. So number 4, right, this is all about calories in fruits versus vegetables. All right, so it says the double box plot shows the number of calories per serving for various fruits and vegetables. All right, so obviously the range is between 0 calories all the way to 200 calories. Okay, so I'm checking out, of course, step 1 is find the medians. So our medians for, I'll put fruits and vegetables, our medians, well, the median for fruit is 100. The median for vegetables is 50. Now, if we're talking about interquartile range, okay, for fruits is between 125 and 50. Okay, between the boxes here, first and third quartile. So 125 actually minus 50 is 75. 75 calories is the interquartile range there. And for the vegetables, 75 and 25, well, 75 minus 25 is 50. Okay, so I have our information for both of those. And if you notice, I'm finding the information first and then I'm going to write about it, which is okay either way. All right, so here's an example of what I can write. I can say the median of the calories per serving for fruit is 100 calories, while it is 50 calories for vegetables. Then I'm going to mention the interquartile range. So the interquartile range for fruits is 75 calories, while it is 50 calories for vegetables. And then, right, we need to make our inference, our very last part. I just stated both interquartile range and the median. So if you take a look, right, Obviously, the extreme is way bigger on fruits, but again, extremes can be misleading sometimes. We need to make sure we take a look. Well, take a look at the top 50%, between 100 to 200 calories. Look at the top 50% here. It's only 50 to 100 calories. So, I mean, it's pretty safe to say that if you look at this whole thing, fruits have more calories. So I could just say, in conclusion, fruits contain more calories overall. I always like putting that overall there because, again, right, some vegetables have 100, some fruits have only 25, but overall, talking about it, you can come to that conclusion. Okay, questions about that? Okay? All right, now I do have one more type of problem. This is a bittersweet problem because there's more math but less writing. Okay? So here's the one I want to talk about with you guys. Let's go ahead and stick it to this side. Let's take a look at problem number 2. Okay, I'm going to do problem number 2 in blue because now we're looking at a double dot plot. If you take a look at the double dot plot, okay, take a look at the number lines. They're exactly the same. They're stacked on each other. Okay? So, number 2 says the double dot plot shows the weights in pounds of several house cats and small dogs. Not large dogs, but small dogs. Okay, the top one's house cats, small dogs on the bottom. It's weight in pounds. All right, so remember what we talked about. Like, for example, house cats, you have 11 pounds. You have 3 house cats that weigh 11 pounds. In comparison, right, three small dogs weighed 9 pounds. Okay, so just reviewing how to read this. All right, so here we go. The steps are the same. Here's the difference. For this kind of problem, dot plot, we're not talking about the median anymore. We're talking about the mean. We're talking about the average, adding them up and dividing like we did last lesson. Okay, that's what I mean by we have more to do, more math to do. So here's what we're going to do. Okay? With this, step 1 being the mean, I'm going to go ahead and this is going to be, I'll put HC for house cats. Okay? So, when I complete this, I'm going to go ahead and add up 9, 2 10s, 3 11s, 2 12s, and a 13. We're going to add those up. I'll use a calculator to add them. 9 plus 2 10s is 20. Plus 3 11s is 33. Plus 2 12s is 24. Plus the 13. I get 99. Now, remember, I need to now divide by however many I added up. 1, 2, 3, 4, 5, 6, 7, 8, 9. I added up 9, so I divide by 9. Guys, our mean for house cats is 11. 11 pounds. That's our mean. Now, sticking with step 1, the second part, I need to now find the mean. I'll put SD for small dogs. So here we go. 6, 7, 2 8s, 3 9s, 2 10s, an 11, and a 12. Using my calculator, 6 plus 7, 2 8s is 16, 3 9s is 27, 2 10s is 20, plus 11 plus 12 equals also 99. But take a look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They actually found the weight of 11 small dogs. So I need to divide by 11, which gives me the mean for small dogs, as 9. Now, step 2, right? There is no step 2 because if we were to do this properly, we would be finding the mean absolute deviation. Okay, we're not going to go over that right now. You will talk more about it in 8th grade, but I would talk about the mean absolute deviation because we dealt with a mean. We don't have to worry about that today. All right, so it's going to cause less writing. More math and calculations, but less writing. So here we go. I can then go ahead and, I guess, complete or write down step 1. And I put the mean weight of house cats. Let me box this in where you guys can see it a little bit better. Is 11 pounds. Don't forget our units. While it is 9 pounds for small dogs. So kind of staying consistent, I'll just go straight to step 3, right? Because we'll just say, oh, there's no step 2 here. We'll say step 3, and that is, in conclusion, if we're comparing the average weight, right? In conclusion, the house cats weigh more overall. Taking a look here, you might want to write all this on a separate piece of paper, right? If you're showing your work on those. So a little more calculations. You're dealing with the mean, the average, okay? But that's all you're dealing with. You don't have to worry about the variation when it comes to the dot plots, okay? Any questions about those type of graphs? All right, guys, so when it comes to comparing populations, that's what we're looking at.